Okay, so we know that slope is rise divided by run. And we want to write down the simplest possible relationship so we don't get confused. Okay? Slope is rise over run, so the slope is -8 reciprocal seconds. And that equals the rise, which is of course what we don't know, divided by the run, which is 2 millimeters, right? Well then, if we multiply both sides by 2 millimeters, we get this, and the rise is 2 times -8, which is okay, well, you know, we got a problem here. My -8 reciprocal seconds that I glibly wrote down here wasn't right. Because it's clearly, that's going to give us -16 millimeters, right? And we've only got 8 millimeters per second, and we've only got 8 millimeters per second, right? So that's clearly wrong because I just forgot to write down my 5 here. Okay? -8/5, and then I didn't use common sense. Now, of course, I knew I'd done that, and I was just trying to illustrate what happens if you're not careful.
Right.
So it's -8/5 reciprocal seconds. Now we get -16/5, right? Okay? And it's going to be millimeters seconds to the -1, which is, of course, millimeters per second. And that gives us 3.2. Okay? And I think I said something about 4.8 and 3/5 of 8. So why would 3/5 of 8 still 24/5? That doesn't jive with this. So, you know, I had some kind of a brain lapse.
But this one right here is not 3/5.
Oh, that's the rise. Never mind.
Yeah.
Never mind. Like I say,
Yeah.
weather or something's got me a little fuzzy right now. And that's my excuse, you know, along with the shoulder sticking. Okay, so there's your rise. Okay, then we easily find, well, what are we doing next? Now that we've got the rise, we take that and put it together with the left altitude to get the right altitude, right? Well, the right altitude equals the left altitude plus the rise, right? And that's a pretty obvious statement. We could say rise equals right altitude minus left altitude. Okay? But this is just as intuitive as that. So, and if it isn't, we do want to go back to the simplest statement we're sure we completely understand, and then do the algebra carefully, like I don't. Okay, so the right altitude then would be the 8 millimeters per second plus the negative, and I lost my negative sign there. There it is, -16/5 millimeter per second, which then equals 24/5 millimeter per second, or 4.8 millimeters per second, without going through the details. You know, common denominator would be 5 millimeters, or you know, just 5 with the units as they are. So you'd have 40/5, and 40 minus 16 is 24, and so forth. Okay? So we usually get the right altitude, right? And then once we have the right altitude, it looks like what we want to do is put that together with the left altitude to get the average altitude, right? Well, the average altitude is the average of the right and left altitude, right? And I'm not going to write out the details. We've already got the scheme, and these are very easy calculations. This is probably the hardest one. It's not hard. Okay, so that's going to be 8 millimeters per second. We'll go with decimals because decimals are nice and neat and easy. Okay, but we could as easily do it in fractions and should be able to do that. And that then gives us what? 12.8 divided by 2, 6.4 millimeters per second, right? So the area is the average altitude times the width, and that's 6.4 millimeters per second multiplied by the width, which is 2 millimeters. And we're getting 12.8 millimeters squared per second, which is kind of weird. Okay? So, what is the meaning of all this? I'll tell you in advance, this doesn't have much of a meaning. Okay? And we'll see why. But the thing that we're really trying to find is what? Why do we even bother doing this? Well, we're trying to find the speed at r equals 2 millimeters, right? And as I said, there are easier ways to find it, but this is an alternative way. Okay? I would say either use proportional reasoning, which is pretty much equivalent to similar triangles, or do a linear model, linear function, which is also easy to do. But in this case, what aspect of this trapezoid is going to correspond to the flow speed at 2 millimeters?
Right altitude.
Yeah, because we're doing flow speeds here, and we've got distances here. Okay, so this is the flow speed at the center at r equals 0, as we kind of specified here, right? So when r is 2 millimeters, well, that means we're going to be here, and this altitude is going to give it to us, right? And of course, this will be the same as the altitude would be here. Okay? So really what we were looking for is, here's our speed. At r equals 2 millimeters, just by understanding what the trapezoid is telling us and what the meanings of the various aspects of the trapezoid are. Okay? Now, the average altitude does have a significant interpretation. That's kind of the average speed between the two, right? So this is the average of the r equals 0 and r equals 2 millimeter speeds. Okay? But when we multiply the speed by the 2 millimeters, that doesn't have any significant meaning. Now, if this was a time interval, then multiplying the average speed by the time interval would give us how far we went. Okay? But we don't have that information from this trapezoid. So this is speed times distance is usually meaningless. Okay? There's really no good interpretation of that in most contexts. If you struggle hard enough, you might find a context where it might be relevant. Okay? Okay. So that's how we can use trapezoids, and this is mainly, as I say, this probably isn't the way you would figure the speed, but you could. But it's a good illustration of how we analyze a trapezoid. This is the same thing we always do. We write down our quantities, we identify the ones we know, and then the reasoning is always quite simple. You just draw arrows from what you know, a couple of things that you know to something you can determine. It's always two things will give you another one, as it was in this case. Okay? I mean, you might be given the two altitudes in the area. What are you going to do with that? Okay. Well, two altitudes give the average altitude, divide the area by the average altitude, you get the width, right?
Yeah.
Now, you won't see it that quickly until you do a few, but it's always that simple. It's never conceptually difficult to deal with these quantities. However, interpretation, you get down to this, that might have had an interpretation that would have been mysterious to you. But if you come down to the fact that, well, speed times distance, then what's that mean? Nothing I can think of. Okay? Maybe there's a meaning, so maybe I just don't know how to interpret it. But that's as far as I can go. Okay? Okay, well, let's move on.